Chapter 1 was where we learned all these vocabulary words and all sorts of new notations and how they applied to all the basic functions. You're going to have to take out your 12 basic functions sheet and study it and make sure you know all the graph shapes. This video will go through what each of these words mean and some algebra skills from these chapters. When you're answering questions about domain, domain is all about restrictions. You could answer domain questions by looking at the graph, but really you can look at the equation and ask yourself, well, here's x squared. Well, what can I square? I can square anything. And because I can square anything, the domain is all real numbers, which in proper notation is negative infinity to infinity. But when you look right here, you know you can't take the square root of a negative number. That comes out complex. So the restrictions here would be x has to be greater than or equal to 3, because if x were 2, you'd have a negative number. So this domain starts at 3 and goes to infinity. When you look at this and think about, well, what can't happen? Here, I can't have 0 on the bottom of the fraction, so x cannot be equal to 1. And if I write that in proper notation, keeping in mind on the test, everything has to be written in proper notation. It goes from negative infinity to 1, union 1 to infinity. So whereas you can get away with answering a domain question without a graph, range is all about taking a look at what the graph looks like and being able to answer that question about the up and down of the graph. So if I were looking at, let's say, y equals 2 minus x squared, I would have to know that that graph is shifted up 2, that it's a parabola, that it's upside down, and now as I look at that function, it goes down forever and it goes up to 2, so the range goes from negative infinity up to 2. So domain is about restrictions, range is about looks. Domain is left and right, range is up and down. So local extrema is about local maximums and minimums, but in the world of parabolas, what it's all about is the vertex. And most of these types of questions will be on the calculator portion of the test, but you will have to be able to find the vertex of a parabola, and you do that by going x equals negative b over 2 times a. In this case, that's 1. Substituting that number into the equation, and in this case, you end up with 2 minus 4, which is negative 2. And so this graph has a vertex at positive 1 and negative 2. If you were to factor it, it also has zeros of 0 and 2. This parabola faces up, and it has what's called here a local minimum, or in this case it's just a vertex or a minimum, at 1, negative 2. When you're asking questions about boundedness, you're just looking at the graph. This goes up forever, it goes down forever, it's unbounded. If you look at a graph of an absolute value, this graph would be bounded below. So to answer boundedness questions, you take a look and just say if it is or if it isn't. So question about symmetry is really a secret question about whether a function is even or odd. In an even function, it's symmetric across the y-axis right here, and in an odd function, it's a 180-degree rotational symmetry. But the main way you might find it is to answer this type of question. Like, let's say you had f of x equals 1 over x. If I were to put a negative into that function, I would get 1 over negative x. These right here are opposites, and so if they're opposites, it's an odd function. This is a weird one. It says increasing and decreasing, but it wants the answer left to right, which doesn't seem so obvious, which is why people miss it on the tests. So let's say I had this function, and I'm going to look at this section of the function, and I'm also going to look at the red section of the function. I would say that this function right here is increasing from negative infinity to 0, and right here it is decreasing from 0 to infinity. So you're answering a question about up and down, but you're saying it in the domain from left to right. End behavior is what's happening to a graph as it's heading off to positive infinity or off to negative infinity in the x direction. So when you take a look at end behavior, think about what the graph's doing, which means you really should go back and watch that little kid in front of the piano video about which direction graphs are going. For example, if you had y equals absolute value of x, you should know that the shape of that graph is a V, and so the limit as x goes to either positive or negative infinity, both sides of the graph are going up, so the limit is infinity. But if you look at one of the graphs we've been doing recently, like an exponential graph, if you were to sketch that function, it looks like this. And so this graph is going to have two different limits. One is going to be as the graph approaches infinity, and to the right this graph is actually going up, so it's positive infinity. But if we look at this section right here, its limit as x goes to negative infinity is 0, because it's approaching. And then keep in mind, if you did something like shift the graph up 2, then that asymptote would get shifted up 2, and the new limit to negative infinity would be 2. When you write vertical asymptotes and limit notation, you have to say which direction it's approaching from. So we're approaching the asymptote positive 1 from the right. The graph is going up. For this next graph, we're approaching infinity as we go left and right, but the graph is approaching the line y equals 4. I saved some room for some algebra type stuff. When you're doing slope, you should be able to do slope in your head at this point in your life. It's the change in y over the change in x. And so if I'm looking at this problem above, and I'm looking at y goes from negative 3 to 4, so it goes up 7. But x is going from 5 to 2, which means it's going to the left 3. And if you were asked about the perpendicular slope, to find the perpendicular slope, you would flip that number over and change the sign. And then I always see people kill this problem because they try to expand. If you notice that something's all nice and factored and squared, you don't want to multiply it out. You want to divide by 5, isolate the squared term, and then after you isolate the squared term, negative 5. After you isolate the squared term, then square root both sides. So x minus 1 squared equals negative 4. Square root both sides, x equals negative 1 plus or minus 2y. Now, even though this doesn't have any real roots, if this problem were a parabola that you were trying to graph, you would now know that the x value of the vertex was -1. And you could substitute that back into the equation to get the y value of the vertex. Some quick tips about parabola shape. If you have a base function for a parabola, you know that's over 1 up 1. So, because there's a 1 in front of the x squared. But if I throw a 2 in front of it, that vertical stretch makes it over 1 up 2. And if I throw a 3 in front of it, the vertical stretch makes it over 1 up 3. And if I throw a half in front of it, it makes it over 1 up a half, which actually also comes out to over 2 up 2. So like 1/2 would be over 2 up 2, 1/3 would be over 3 up 3, 1/4 would be over 4 up 4. Makes it easier to spot the shape just by looking at how far over and up on the first point they go.